Okay, so today we are going to start with circles, of course. So circles, we have already studied this in grade 9, as well as we had a chapter in grade 10 as well, which basically concentrated on areas of circles and areas of sector, area of segment, that all things. So in this particular chapter, we are going to focus on the tangents. Anybody who could tell me what are tangents? What do you know about tangents? Or you have no clue what are exactly tangents?
So a particular, I think a particular line which touches the circle at single point.
Okay, touches the circle at single point. Cool. All right. What is a chord? What is a chord?
Passes through the circle and touches it at 2 points.
Okay. Now, what is the difference between a segment and a chord? Sorry, between a secant and a chord. Secant and a chord. Yeah.
A chord is a line segment that starts and ends from 2 points on the circle, and a secant is a line, so it does not have any starting
Exactly.
or ending points.
Cool, cool, cool. So basically a segment, secant is a line which passes through the circle, and chord is a line segment. So line segment is something which has fixed endpoints, right? So look at these three figures. Can you tell me which one is the chord over here? Which figure denotes the chord?
None of them.
None of them is a chord.
Yes, because the second figure is a second.
Yeah, it's a secant, but like AB is still a chord, no? PQ is a
Yeah,
secant.
yeah.
So AB is still a chord. So this AB is a chord. Okay, what about figure 1? What do we call this line? PQ. So since this line is not intersecting to the circle, so we say that this is a non-intersecting line to the circle. Okay. What about the third figure?
A tangent.
Perfect. Tangent. So basically tangent is a line, a very special line which touches the circle at only one point. You all know that circle is a locus of point which is at a fixed distance from a fixed point called as the center of the circle, right? So it's a special line which touches the circle at only one point. Yes,
So the
Ananya.
tangent is always outside the circle, or is it like
It's
inside
always
outside?
touching the circle. You can't say it's
Okay.
always outside. It
So
touches
it is
the
only at a one. It's only at a point, 1 point, right?
exactly. It's only at one point. Okay. So yeah, that's about tangent. That's something unique about tangent, that it only touches at one point. Okay. So tangent of a circle is basically, it looks like this. This PQ is a tangent and it is touching the circle at only one point, which is A. So you can write like the definition of the tangent of a circle. It's a line which touches the circle at only one point. Okay. So yeah, next up we have, what is this A point called as to be? So since this point is touching, like the line and the circle are touching at only one point, this particular point A is known as the point of contact. This is point of contact, right? Length, then we have, okay, you can say that this line PQ is the tangent, PQ is tangent, A is the point of contact, right? Let's move on to some more terms related to the tangent. Yeah, that is what I told. This point of contact is the point at which the tangent intersects the circle. So the point at which the tangent is intersecting, that will be of course a single point. So this point is known as the point of contact. Okay, there is one more term called as the normal. Anybody who knows what is a normal? Normal. So normal is basically perpendicular to the tangent. Okay, let's say there's a point C. You want to draw a tangent on this. So the tangent would look like this, only touching at point C, right? So there is one more line which is perpendicular to the tangent, and that line is known as the normal. So a line which is perpendicular to the tangent and passing through this point of contact is known as the normal. So this particular line is the normal. This line is perpendicular to the tangent. It is passing through the point of contact. And since this is a circle, this normal always passes through the center of the circle. Okay, so normal has three properties. One is it is perpendicular to the tangent. It passes through the point of contact. The third is it passes through the center of the circle. Okay, let me name this. Let's say this is A, this is B. So AB is a normal, right? So the line containing the radius through the point of contact, or more precisely, you can write the three properties, that it is perpendicular to the tangent, okay, passes through the center of the circle, and the last thing is that it passes through the point of contact. Okay, any doubts, any confusions in normal and tangent? Please guys, yes या no बोल दो ताकि मुझे पता चल जाएगा, please.
No, sir.
Great. So there is one more term called as the length of the tangent. So length of the segment from the external point to a point of contact with the circle. Okay, let me make a circle like this, right? I have a point over here. I try to make a tangent from this particular point. So it will look like this, like it's touching at this point. Let's say this point is T. Assume that this is touching at one point. So what will be the length of the tangent in this case? How do we define the length of the tangent? So the length of the tangent will be the point where you start making the tangent and the point where the tangent is touching to the circle. Okay, so length of the tangent will be equal to OD. Length of tangent is equal to OD. All right. Any confusions? I guess it's easy till now. We have studied tangent, we have studied normal, and there are some terms related to the tangent, the point of contact, and the length of the tangent. Okay. Now let's move to theorem 1. As I said, there are only two theorems on the chapter, like two theorems in the chapter, and all of the questions revolve around these two theorems. Okay. So theorem 1 says the tangent at any point of a circle is perpendicular to the radius to the point of contact. First of all, tell me one thing, guys. Let's say you have a circle and you have a chord. let's say this is the center. If I draw perpendicular from the center to this chord AB, what will happen to this chord? So the question is, you have a circle with center O, you have a chord AB, you draw perpendicular from the center. So tell me whether this C will be the midpoint of AB or not.
Yes, sir. So the OC will be equal to CB. AC equals to CB.
Exactly. AC is equal to CB. So the thing is, perpendicular from center bisects the chord, right? You have studied this in your grade 9. The perpendicular from the center bisects the chord. All right. So, and what is the shortest distance between 2 points? You might have studied this in physics. Shortest distance between 2 points. Is it the perpendicular distance? So basically, perpendicular is the shortest distance between 2 points. Let's read this statement properly. The tangent at any point of a circle. So I'll make a circle first. Let's say this is my circle. I have a tangent at any point. Let's say this is my any point. The point is, say, A. I have to make a tangent at this point. Okay, agreed. Then we have the tangent at any point of a circle is perpendicular to the radius. So this is my center and this is my radius, right? We have to prove that this particular line OA is perpendicular to the tangent. Okay. Statement से जो मैंने figure बनाया वो समझ आया सबको? We have a circle, we have a point, we have to make a tangent on that point, and we have to prove that this particular line, like which is passing through the radius is perpendicular to this tangent. Okay. Let's do the proof on the next slide. So this is our circle. This is our point. Let's say this is A. This is my tangent. Center of the circle. This is the radius. Okay. So what I'm doing is a very simple proof, nothing mathematical in this. So what you have to do is I'm taking a point OQ. Let's say there is a point Q. I'm joining this via dotted line. I'm constructing this. So in the construction, you can write join OQ. Yeah, join OQ. This is the line CD. Okay. So what we have to prove is that OA is perpendicular to CD. Okay. Let's go to the proof part. So the thing is, this point, like, can we say that OQ is greater than OA from the figure itself? Can we say that? कि OQ एक दूर point है and this point, this distance OQ will obviously be greater than OA.
Yes, sir.
Yes. Now, as I shift this point towards Q, like as I shift this point Q right towards A, can you tell me at which point we'll have the shortest distance?
Sir, at A.
At point A. Okay. So at point A, we'll have the shortest distance. So as you know, the shortest distance between 2 points is the perpendicular distance between those 2 points, right? So since for every point Q, the shortest distance will be at point A, therefore we can say that this line segment, this radius OA will be perpendicular to the tangent which we have, which is CD. So at point A, we have the shortest distance. Therefore, we can say that OA is perpendicular to tangent or to the line CD since perpendicular is the shortest distance between 2 points. Perpendicular distance is the shortest distance between 2 points.
Sir,
Yeah.
can you explain once more? I didn't understand
Okay.
this.
Okay. See, we have a point OQ. We have a point Q. Right. Give me 1 second. Yeah. Sorry. So see, we have a point Q on this line segment CD. Right. We have this. We have constructed this OQ. So till when we can say that this OQ will be greater than OA? Till which point? मान लो मैं Q को मूव कर रहा हूं, मैं कब तक ये कह सकता हूं कि OQ बड़ा होगा OA से?
Till it reaches point A.
Till it reaches point A. So जैसे ही point, it is only a specific condition कि OQ will be equal to OA when Q coincides with A, right? There's only one point at which OQ will become equal to OA when this point Q reaches the point A. फिर उसके बाद अगर वापस से आगे निकल जाएगा तो OQ will be again greater than OA, right?
Yes,
अगर
sir.
Q, हाँ, अगर Q इस पॉइंट पे भी आ जाएगा, Q इधर इस साइड पे भी आ जाएगा तो भी OQ will be greater than OA. So what I am saying is this point Q when coincides with point A, I can say that this OA will be the shortest distance of the line. Basically हम लोग ये करना
Yes,
चाह रहे हैं
sir.
कि एक सेंटर से हम लोग वो डिस्टेंस देख रहे हैं जहां पे वो लाइन से शॉर्टेस्ट डिस्टेंस हो. From the radius, from the center, we are looking for a point where we get the shortest distance from the tangent. So what I am trying to say using this proof is that if you change the slider of Q, if you change the point Q, there will be only one point A. There will be only one point at which this distance will be shortest, and that point is over here, which is point A. Okay. So OA is the shortest distance from the tangent, and this shortest distance is perpendicular from the, like, the radius is perpendicular to the tangent.
Okay,
So
sir, I
basic,
got it.
yeah, the catch is just this much, ki radius is perpendicular to the tangent. So let's say you have any circle, you have a tangent right at this point, there is a center over here, so this radius is always perpendicular to the tangent. Okay, let's move on. So okay, now we have to prove that the tangents drawn at the ends of a diameter of a circle are parallel. मैं proof वाले questions एक बार खुद से solve करके बताता हूँ, तुम लोग बताना अगर कोई doubt होगा तो, ठीक है? So for 10.2.4, everyone knows what is the diameter and what is the radius? So let's say this is our center of circle C and this is the diameter. We have to prove that the tangents drawn at the ends of the diameter. So this is one end, which is right over here, which is A, and this is the second end, B, right? I have to draw a tangent at point A. I have to draw a tangent at point B. What I have to prove is that these two tangents are parallel to each other. Anyone, any clue ki how can we prove this? Okay, first of all, can I say that this CA will be perpendicular to DE? Because from the previous theorem, I know that the radius is perpendicular to the tangent, right?
Yes,
Yes,
sir.
sir.
Okay. Similarly, can I say that this CB will be perpendicular to FG?
Yes, sir.
So what I have as of now is angle DAC is equal to 90 degrees and angle CBG is also equal to 90 degrees. Now, since both of them are equal to 90 degree, I can say DAC will be equal to CBG, right? Now, are they making a
Yes,
pair
sir.
of alternate interior angles?
Yes, sir.
Yes, sir.
So alternate interior angles तभी exist करते हैं जब दो lines parallel होती है.
Yes, sir.
So अभी हम लोग क्या बोल रहे हैं, क्योंकि ये दोनों angles equal हैं and they are also alternate interior angles, therefore we can say that DE will be parallel to FG. Since both of the angles are, so these two angles are equal, they are also making a pair of alternate interior angles. Therefore, we can say that DE will be parallel to FG. Any doubts till this point? Like for this question?
No, sir.
No, sir.
Right. Okay. So first theorem, a super easy theorem. It's just that the radius is perpendicular to the tangent. That is what you have to remember. Okay. Let's move on. We'll solve the second one later. So we'll now see the number of tangents from a point on the circle or outside the circle. So I'll give you three cases. The first case is when the point is inside the circle. Let's say the point P. Second is when the point P is on the circle. The third is when the point P is outside the circle. So can you tell me the number of tangents possible for the first case?
Zero.
Zero. How many of you agree with it?
So I also think it should be 0.
Zero. Why zero?
Because the tangent is also always outside the circle and touching on the circle. So it cannot be.
Yeah, you can't say it's outside the circle. I mean outside the circle in the sense it should just touch the circle, right? At only one point. So अगर तुम यहाँ से कोई भी tangent draw करना चाहोगे तो वो हमेशा circle को intersect करेगा ना. So circle को क्योंकि वो intersect करेगा, therefore the number of tangents possible is 0. Right? For this particular point, second case, how many tangents are possible?
None.
Sorry, I
Oh.
didn't.
No, for the second one.
Yeah,
I think for the second one it should be 1.
one exactly. There is only one tangent possible at a point because उस point से pass होता हुआ एक ही tangent बन सकता है, ये वाला, right? और कोई भी tangent होगा तो उसका point of contact कुछ और होगा. मैंने बोला है कि इस point पे, particularly on this point, how many tangents can be drawn? So for a point on the circle, there is only one tangent possible. What about the third case?
It will be none.
None, no tangent.
Right. Yes, because like the point of contact is not on the circle.
Yeah, but you can
Oh.
make, no? Let's say I make a tangent like this. We have a point of contact over here.
So, sir, two tangents.
Exactly, two tangents. So from a point outside the circle, you can make two tangents, right? PD and PE are these two tangents. Okay, so for a point inside the circle, no tangent is possible. For a point on the circle, one tangent possible. For a point outside the circle, two tangents are possible. Any doubts? किसी को लग रहा है कि बाहर वाले पॉइंट से सर I can make more than two tangents? या सर टू कैसे
sir.
बन रहे हैं? या yes.
मतलब no sir, no doubt.
All right. Okay. Let's move on to theorem 2 then. So the theorem 2 says the lengths of tangent drawn from an external point to a circle are equal. So again, I'll go line by line. The lengths of a tangent drawn from an external point. So external point means a point which is outside the circle. So let's say we have a circle like this. The center is C right over here. I have a point outside the circle. The point outside the circle will be this. Okay. And we are drawing two tangents. So these are the two tangents. Assume this is a tangent only. It's touching at only one point. Let's say this is A and this is B. So they are saying the lengths of the tangent. So what are the length of the tangent over here for these two particular tangents? What is the length of the tangent? The
So,
yeah,
PB and
exactly. PB and PA. So basically the length of the tangent is defined कि जहां से तुमने tangent draw करना चालू किया till the point of contact. So हमने draw करना चालू किया था P से and the point of contacts are B and A. So PB and PA are the length of the tangents. So what is theorem 2 saying? That the length of these two tangents will be equal. So theorem ने तो बोल दिया but सर हमको तो prove करके बताओ कि कैसे होंगे ये दोनों tangents equal. So prove भी कर लेते हैं. Give me a second, I'll have to add a slide. Yeah. Okay. So let's say you have a circle like this. This is the external point P. This is my one of the tangent. Point of contact is A. This is my second tangent. The point of contact is B. Okay. So we are given PA and PB are two tangents. So whenever you prove a theorem, you have to write everything given, to prove, construction, everything. Okay. What we have to prove is we have to prove PA is equal to PB. So let's say this is the center of the circle. What I'm constructing is OA and OB. I'm constructing OA and OB. Join OA and OB. Also, I'm joining this line, OP. So anybody who could like tell me कि sir ऐसे ऐसे हम लोग prove कर सकते हैं उससे PA equal to PB आ जाएगा? I mean a random guess. जरूरी नहीं कि वो सही हो. कि सर हम लोग yes Abhishek.
Yes, sir. So first we can prove that PO is equals to PO because it is the same side, and OA is equals to OB because they are radius of the circle.
Agreed.
Yeah, so it will be equal.
No, see, you are trying to prove POA and POB as congruent triangles.
Yeah.
And then using CPCT, you will say PA is equal to PB.
Yeah.
Okay. So you missed one part. Since PA
Can I
and
tell?
PB. Yeah, sure.
Sir, the angle OAP is equal to OBP, which is
And
90
how much it
degrees.
is? 90 degrees.
90
Exactly.
degrees.
Why 90 degrees?
Because the angle,
That is because since PA,
the
yeah,
It's perpendicular to.
not the perpendicular rule. It's basically like the radius, like tangent का एक property होता है कि the radius is always perpendicular to the tangent. Okay, the theorem one which we studied, right? So proof में what are we going to do is we are trying to prove that triangle POA and POB are congruent to each other. So in triangle POA and triangle POB, the very first thing is angle PAO is equal to angle OBP equal to 90 degree, and the reason behind this is PA and PB are the tangents to the circle. Okay. Also, we have OP equal to OP, which is common side. And we have OA equal to OB because they are the radius of the circle. Now, which rule is making these two triangles congruent? Which congruence rule? Is it SAS?
RHS.
RHS, perfect. We have a right angle, we have the hypotenuse, and we have the radius. So triangle POA is congruent to triangle POB, and the rule is by RHS. So therefore, by corresponding parts of corresponding triangles, I can say PA will be equal to PB by CPCT. Okay, a very simple proof. You just have to remember कि radius is always perpendicular to the tangent. Okay. उसके बाद इन दोनों triangles को हमने congruent prove करा and that's all. By CPCT you can say PA is equal to PB. Okay, any doubts till this point?
No, sir.
No,
All
sir.
clear? So एक बार quickly मैं sum up करता हूँ कि वो दोनों theorems में हमने क्या क्या पढ़ा है. So first theorem said if you have a circle, okay, you have a tangent at any point, what you can say is that this point, like this tangent, is perpendicular to the radius. Okay, what is the second theorem saying? Let's say you have a point outside the circle and you draw two tangents from this particular point. The second theorem says that the length of these two tangents will be equal. PA will be equal to PB. And the first theorem is saying the radius is perpendicular to the tangent. That's all. Okay, let's try some questions now. Okay, try the fifth 10.1.5. This particular question. This one. Okay, Ritvik, correct. Aditya, correct. Neil, correct. Amay, Adit, sorry, Amay and Raghav and Ananya. Abhishek, correct. Sorry, I forgot you. Abhishek, correct. अच्छा, who is confused कि सर कैसे करना है, नहीं समझ आ रहा. Anyone? Okay. So देखो पैरेलल टेंजेंट्स कब पॉसिबल है, जब हम टेंजेंट्स बनाए डायमीटर के एंड पे. अभी हमने क्वेश्चन किया था कि if we have a diameter and if we draw tangents at the end points of a diameter, the tangents are parallel, right? So equation में क्या बोला है कि we have the radius of the circle, the radius is 5. So we have to find the distance between two parallel tangents. So ये दो हमारे parallel tangents हैं, इनके बीच में distance क्या है, diameter के equal, right? So diameter is the distance between these two tangents. So diameter will be equal to 2 times of radius, which is equal to 10. Okay. All right, go to the sixth question, this one. Do it quickly, very easy one. Okay. All right, a very simple question. How many tangents can be drawn to a circle from a point outside the circle? So of course it is 2. We got 10 for this. Okay, at which point a tangent is, yeah, this point. What is this point called? A point at which the tangent is perpendicular to the radius. What is that point called? Point of contact, not intersection. Point of contact. It's a more precise term. Point of contact. Cool. Next, eighth question. Which term will you use for a line which intersect a circle at two distinct points? Secant, exactly. Remember guys, chord नहीं होगा क्योंकि यहाँ line लिखा हुआ है. Line segment होता तो chord होता. यहाँ line लिखा हुआ है तो the answer will be secant. Ninth question is again the repeat of this. Okay, find the distance between two parallel tangents of radius 3. It's again the same question, so its answer 6 हो जाएगा. No problem. ठीक है. Let's move on. Okay, try this question now. Okay, Ritvik and Aditya has answered. Cool. I'll make the figure and let's see उसके बाद कौन-कौन figure out कर पाता है. So we have a point Q. The length of the tangent to the circle is 24 centimeter and the distance of Q from the center is 25 centimeter. Okay. So we have a circle like this. there is some point Q outside the circle. We are making a tangent from this point. Okay. So this is the point of contact. Let's say it's A. This is my center of circle. We are given that the distance of Q from the center of the circle is 25 centimeters. So this distance is 25 centimeters, right? Of course, the radius is perpendicular to the tangent. So OA will be perpendicular to the tangent. And we have one more information that the length of the tangent is 24 centimeters. We just have to calculate this OA. Can we use the Pythagoras theorem over here? Anya?
So,
Yeah, can we use the Pythagoras theorem?
yes, so it's forming a right triangle, so we can.
Yeah, so using that, we'll be able to find out the length of OA.
Yes, sir.
Okay, so tell me like what will be the length of OA then?
Yes, sir. I'll calculate and tell.
Okay. So OQ whole square is equal to OA the whole square plus QA the whole square, right? Just plug in the values of whatever you have and calculate the value of OA from here. Abhishek, Neil, Ritvik, Aditya, correct. Nanya, 7, great. Amey and Raghav, any doubts? Okay, try this question. Okay, Neil has answered, Aditya has answered, correct. Ritvik, correct. अच्छा, concentric circles सबको पता है क्या होता है? Concentric circles.
Yes, sir.
It's a circle inside a circle, right? Circles with the same center. Ananya, incorrect. You have made a very small mistake. Okay. So we have two concentric circles. Let's say this is the first one. This is the second one. Okay. Right. Ananya. So what are we given is that the radius of these two circles are 3 and 5. So this is 3. And let's say this is 5. So we have to find the length of the chord of the larger circle which touches the smaller circle. So inner wale circle ke liye the chord is the tangent, and for the larger circle it's the chord. So will it look something like this? It is a chord for the larger circle and it is a tangent for the smaller circle. Right? So OA will be perpendicular to CD. Therefore, using the Pythagoras theorem, I can say OC whole square is equal to OA whole square plus CA whole square. Right? OC whole square is 25 is equal to 9 plus CA whole square. So CA whole square is equal to 16. That means CA will be equal to 4. Right? So this particular length is equal to 4. But we have to find the length of the chord. Now, since we know that a perpendicular from the center bisects the chord, so we can say that CD will be equal to CA plus AD. But since this perpendicular from the center bisects the chord, I can say CA is equal to AD. Therefore, CD will be equal to 2 times of CA. So 2 times of 4 is equal to 8. Okay. Any doubts, Abhishek?
No, sir.
All right. Try this. Ritvik, correct? सेम एप्लीकेशन पे क्वेश्चन है जो हमने अभी प्रीवियस क्वेश्चन किया. Okay, Aditya, correct. Ananya, correct. What about you, Abhishek, Neil, Amay, Raghav? Neil,
Sir, I'm
correct.
solving.
Okay. So just tell me one thing, you have your subjective papers, right, in your board?
Yes, sir.
So,
Okay. So I'll tell you how to write this particular solution in terms like for your board perspective. Yes, Abhishek, I'm waiting for you. Nine, no. What is 3 plus 3, Abhishek?
Oh, sorry, 6.
Yeah. Okay. So again, let's say we have two circles. I'm just doing this so that you get to know that how to represent this as an answer in your boards. Okay. We have one of the radii as 4, the other one is 5. And this is a chord and the tangent to the smaller circle. So let's say O, A, and B. So first you'll write that OB is perpendicular to AD, and you'll write the reason because like OB is perpendicular to AD because AD is a tangent to OB. AD is a tangent to the smaller circle. Okay. Then you'll write in triangle OBA, sorry, angle OBA is equal to 90 degree. Therefore, we can apply the Pythagoras theorem. So that means OA the whole square is equal to OB the whole square plus BA the whole square. And for this statement, you'll write that this is by Pythagoras theorem. You'll do the calculation and you'll get AB as 3 centimeters. Now, since you have to calculate AD, so you'll write that AB is equal to BD, and the reason is that perpendicular from center bisects the chord. So therefore, what you can say is that AD is equal to 2 times of AB. So 2 times of 3, and this is equal to 6 centimeters. Okay. So basically for every step you are writing, you have to mention what is the proper reason behind it. अब तुम लोग डायरेक्टली AB is equal to BD लिख दोगे या सीधा तुम लोग AD is equal to 2 times of AB कर दोगे, तो you have to mention कि ऐसा क्यों हो रहा है, right? So this is all about how you write in a subjective paper. Okay, try this question now. Okay, what is the first step you are doing in this question? कि क्या figure out कर पा रहे हो, क्या क्या हम लोग निकाल सकते हैं? अच्छा, first tell me what will be the length of PR?
4.
4 centimeter. Everyone agrees to this?
Yes, sir.
Okay, anyone who could tell me the reason why PR is equal to 4 centimeter?
Because the chord is 8 centimeter, and so the center will bisect it, so it will be half, so it will be 4.
Okay, so PR is equal to 4 centimeters. Also, can I say that this whole angle and yeah, this angle will be 90 degrees? This whole angle TPO. Is this statement correct? Because TP
I
is a
think
tangent.
yes, sir.
Yeah. TP is a tangent, and since OP is the radius, I can say that TP will be perpendicular to OP. Also, can I say that this angle will also be 90 degrees?
Yes, sir.
Okay. So angle ORP will also be equal to 90 degrees. Right. Acha. So first I'll apply the Pythagoras theorem in triangle ORP. So in triangle ORP, we have this R as 90 degrees. So I can apply the Pythagoras theorem. I'll have OP whole square is equal to PR whole square plus RO whole square. Okay. What is OP? OP is 5 centimeters. So 25 is equal to PR. PR is 4. So 4 times 4 is 16 plus RO whole square. So from here, I'll have RO as 3 centimeter. So this particular length is 3 centimeter. Okay. Then I'm moving to the triangle in triangle PTO. PTO. I'm taking this TR to be X. I'm taking TR as X centimeters. So in triangle PTO, can I say OT the whole square is equal to PT square plus PO square? Again, using the Pythagoras theorem. What is the value of OT? How much is OT? How much is OT? 3 plus X. OT will be equal to OR plus PR. Yeah, so OT is equal to 3 plus X. So 3 plus X, the whole square, is equal to PT square. We don't know PT because that is what we have to calculate. PT square plus PO square. PO we know, that is 25. Right? So we have one equation from here, that 3 plus X the whole square is equal to PT square plus 25. Now I'll move to the triangle TRP. TRP. This triangle. Since this is 90, this will also be 90. So in TRP. So in triangle TRP, can I say TP the whole square is equal to TR square plus RP square? Right? Since TP is same as PT, so PT whole square is equal to TR. TR is X square plus RP. RP is how much?
4.
4, right? So this will be 16. So using these two equations, can you calculate the value of PT or substitute PT as x square plus 16 in this particular equation? So from 1 and 2, can we say 3 plus x the whole square? PT square is how much? X square plus 16. So x square plus 16 plus 25. Solve this equation and tell me the value of x.
Hello, sir.
Yes,
So,
Deep.
so actually my class started my school's class started. So can I leave now?
Yeah, sure.
Okay. Thank you, sir.
Yeah. X is equal to 16 by 3. Okay. Well, are you sure it will be 16 by 3? Let me solve this. So it will be 9 plus x square plus 2x is equal to, 6x is equal to x square plus 25 plus 16 is how much? 41, right? X square cancels out. It will be 32. X will be equal to 32 divided by 6. So 16 by 3 exactly. X is equal to 16 by 3. So put x as 16 by 3 and calculate the value of PT because we have to calculate the length of TP. Okay, Ananya and Ritvik, both of you are getting 20 by 3. All right. So do you guys actually like ये समझ आया कि how did we manage to calculate the length of PT? We have used two equations. हमने दो equations बनाए, दो right triangles से. Okay, and using that we have calculated the length of PT. Any doubts, Abhishek, Ananya, Ritvik, Aditya, and all the other students present?
No, sir.
All clear? कुछ अभी तक ऐसा कुछ जो नहीं समझ आया हो?
No, sir.
Okay. Okay, so I have a question for you. Let's say we have a circle like this. I'm making a tangent which is of length 10 centimeter. The radius is 5 centimeters. You have to tell me what will be the length of this tangent. PA is 10. You have to tell me the length of PB. Okay, Ritvik has answered. Ritvik, correct? Abhishek, correct? Aditya, Amer, Raghav, Ananya. Acha, Abhishek, how is PV equal to 10 centimeter?
Yes, sir.
How is PV equal to 10 centimeter?
Sir, because of theorem 3.
Theorem 2, can you tell me the statement?
No, sir, I didn't did. I just did it mentally.
Yeah, no, I'm asking the theorem statement. What does the theorem mean actually? That is what I'm asking.
Yeah, so the theorem says means that PA is equals to PB.
Exactly. The tangent from an external point are equal in length. So since PA is equal to 10, so it's actually a mental question that using the theorem, you can easily say PA will be equal to PB and that will be equal to 10 centimeters.
So, sir, when we are writing this
Yeah.
answer, we have to write the theorem also, right?
Yeah. You have to write that from the external point P, we are drawing two tangents P and PB, so they'll be equal in length.
Okay.
Or you can write from any external point, the two tangents drawn are equal in length. Okay, we'll do this afterwards. Yeah. Give me a second. Okay. You can see the screen, right?
Yes, sir.
Okay,
Yes,
try
sir.
the 11th question. Okay, Ritvik has answered. Ritvik, correct. Acha, anybody who could tell me what is the measure of this angle? Except Ritvik. What is the length of this particular angle?
Yes, sir, it will be 40 degree.
40 degree. How can you say that it will be 40 degree?
So because angle OPR will make a 90 degree. So from like
Exactly,
that.
this will be equal to 40 degree. Okay, agreed. Since this is a tangent, OP is a tangent. So sorry, PR is a tangent. So this OP will be perpendicular to PR. Therefore, this whole angle will be 90. And since a part of it is 50, I can say that the other part will be 40. Okay, so we have to calculate POQ. How will we do that?
So we will like find and first we will find angle PQ, which will be 40 degree because the triangle is isosceles because PO is equal to OQ, which is equal to radius.
Great. Since PO is equal to OQ because both of them are the radius, I can say that the triangle is isosceles. So since this is 40, this will also be 40. So uske baad you just have to apply the angle sum property and that's all. So clearly by that you can say that this particular angle will be equal to 100 degrees. Try the 16th question. Okay, Ritvik correct, Abhishek correct. So majorly for the angles wale questions, you have to use the theorem 1 that tangent is perpendicular to the radius. That's all. You'll be able to figure out everything after that. Okay, Ananya, are you stuck? Ananya, Aditya.
Yes, sir. Can you explain?
Okay, so will this angle be 90 degrees? Ananya?
Yes, sir.
Achha, tell me why this will be 90 degrees.
Because of the theorem 1 where
Okay.
the radius is always perpendicular to the tangent.
All right. So what will be the measure of this angle then?
So it would be 60 degrees.
60 degrees. So do x degrees and 60 degrees make a linear pair?
Yes, sir.
So both of them will add up to 180, right? Since it's a
Yes, sir.
straight angle. So x
Yes,
plus
sir.
60 is equal to 180 and there you go. You have found the value of x. So x is equal to 120.
120.
Okay. Try this question. 10 point. Okay, one sec. Before that, yeah, solve the third question.
So the second level one, right?
Yeah, 10.2.3. This one. Again, the catch only lies in this. Okay, somebody has answered. Correct, Ritvik. Nice. Use the theorem 1 again. उसके बाद बहुत easy हो जाएगा question. Abhishek, correct. Great. Ananya, correct. Okay, Abhishek, can you explain why, like, how did you got the answer?
Yes, sir. So first, T will bisect angle O equally, right?
Yeah, why? Why it will bisect?
So because of theorem 2.
Theorem 2 says that these two tangents will be equal.
Yeah, and sorry. So I think,
No, you are actually correct that this angle is bisected
yeah, I'm thinking which
because,
theorem seems
okay, see this OP is equal to OQ because of the radius,
yeah,
and this OT is common in both the triangles.
yeah,
So the two triangles are congruent by SSS. All the three sides are equal.
yes, sir.
Therefore, this angle will be equal to this angle. So I agree that this angle will be equal to 55 degrees.
Hmm.
After
And then
this,
you can just calculate angle TPQ.
TPQ,
PTQ, right?
PTQ. How will you calculate that?
Yeah, so we know that angle TPO is 90 degrees.
Okay.
And now we can calculate angle PTO.
Yeah, this angle will be 35 degrees then.
Yeah, and that angle.
Your voice is too low, Abhishek. I can't hear you.
Yeah, can you hear me now?
Yeah.
Yeah, so and that angle OTQ will also be 35 degrees. So angle PTQ will be 70 degrees.
Perfect. So this will be 70 degrees. Anyone who has some other approach? Because I have an easy approach. See, can I say that these two angles are 90? Because TP and TQ both are tangents, so whole of these angles will be 90. Now in
Yes,
this
sir, and you
quadrilateral,
can use the quadrilateral formula like 90
exactly,
plus 90.
right. So that's more easier than the previous approach. So x plus 90 plus 90 plus 110 is equal to 360. There you go. You have to solve this equation and you calculate the value of x. Okay, great. Let's move on. Okay, try the 17th one. 10.2.17. Everybody is confused here कि how to solve this question. Sir, कुछ values तो है नहीं, then how are you expecting x plus y? See, I'll tell you a trick to solve these questions. So whenever you have like none of the values of the angles mentioned, 90 degrees. I don't know the final answer. Okay. Ritvik, can you explain me your approach? That it would be better then. I mean,
Then I thought because angle QPO is equal to 90 degree now. So angle POQ
okay.
plus angle PQS is also 90 degree. So because of
Okay,
light.
okay, okay. Okay. So let's say this is 90, right? I'll take this angle as theta. I'm taking y as theta. Okay. And I'm trying to calculate every angle in terms of theta itself. So since this is theta, can I say that this angle will be 180 minus theta? Because it's a straight angle. Like on the straight line, the angles sum up to 180.
Yes, sir.
Yes. Okay. What will be this angle then in terms of theta? Or rather, tell me what is the value of x in terms of theta?
Sir, is my answer right? I've sent you on chat.
Yes, Abhishek, correct. So, Abhishek, could you tell me what is the value of x in terms of theta?
180 minus x.
I'm asking x in terms of theta.
No, sir, I've done something like this. So 180 minus x is equals to angle POR, and
Okay, you have done the other way. Okay.
yeah.
All right, Ritvik or Nanya or Aditya, Amay. Simple angle sum property लगानी है. This is 180 minus theta. This is 90. So, what will be the value of this angle in terms of theta? 180 minus theta plus 90 plus, let's say, angle POQ will be equal to 180. 180 cancels out. So POQ will be equal to theta minus 90. Now again, since this is a linear pair, or you can say that it's a straight line, so x will be equal to 180 minus theta minus 90. Sorry, minus theta plus 90. Yes, it will be 180 minus theta minus 90. So x will be equal to 270 minus theta. Okay, so we have both x and y in terms of theta. We took y to be theta. We got x as 270 minus theta. So x plus y will be equal to 270 minus theta plus theta. Theta cancels out and you have the value of x plus y as 270 degrees.
So I did get the value as 270, but I did with another method. So can I say what I did?
Yeah, sure.
So I took P as 90 degree, and so what I did was that OQ, and so I did P plus O plus Q is equal to 180 degree, and I got O and Q as 45 degrees, and finally I
One
need to
second. Why is O and Q like O and Q you will get as 45 degrees when O and Q are equal?
Yes, sir. I think that's what I did. I don't know. I was
But
not
why
sure,
they are
but
equal?
yeah, that's one.
Yeah, you have, like, in geometry you need a reason for everything. So these two lines are of course not equal.
Yes, sir.
PO and PQ.
Okay.
Okay, any doubts in this approach? That how did we calculate x, how did we calculate y, both in terms of theta, and then when you sum it you get 270. Okay, try the 12th question. 12th one. Okay, Ritvik, correct. Abhishek, correct. Nice. Yes, Aditya, Amay, Ananya. Okay, so we are given this particular angle as 50 degrees. So what will be the value of PAB then? Abhishek or Ritvik?
Can you repeat?
What will be the value of PAB, angle PAB?
Sir, I actually did a different method, so I don't know.
Okay, tell me that method then.
Sir, I the like the angle or this because POOB is a quadrilateral. I found that 50 plus 90 plus 90 plus angle AOB is equal to 360 degree. So angle AOB is equal to 130 degree from that. After that,
Okay.
because OA is equal to OB, we can say that angle OAB is equal to angle OBA. And through that,
Okay.
from using the angles and property, you will get the answer as 25.
Exactly. Perfect. I completely agree with your solution. Any other approach for this question? Yes, Abhishek, Ananya.
Yes, sir. I've used the second method. So first, I I remove OP bisects angle bisects 50 degrees. So yeah, and then I found out POB.
POP. Okay.
Yeah, P which is 65 degrees. So angle AOB will be 130 degrees,
All right. All right. Okay. Okay.
and
So any,
triangle
yeah. Yeah, perfect,
yeah,
perfect.
and
Then you apply the angle sum property and that's all, right? Okay. Any doubts in the two methods which we have discussed right now? Yes, Aditya, Amay. Okay. Let's move on. So try the 13th question. I hope you know trigonometry. You have done trigonometry?
Yes, sir.
All right. Okay, check. So is the figure looking like this? Say you have a circle. The tangents are inclined at an angle of 60 degrees. So we have a point outside the circle. These are the two tangents which we have, and this is 60 degrees, right? Okay, Ritvik and Abhishek, correct. So we have the radius of the circle to be 3 centimeters, and we have to calculate the length of the tangents. That means we have to calculate the length of PA and PB. So how can we do this? Anyone who wants to explain?
So you can draw a line from P to the center of the circle. It will
Okay.
divide into the 30 degree.
Mhm.
Then we will use the tan 30, with tan 30 is equal to AO by PA.
AO by PA. Okay. What is the value of tan 30?
1 by root 3.
1 by root 3 is equal to 3 by PA. So from here you get the value of PA as 3 root 3.
Yes.
Okay. Abhishek, did you use the same method?
Yes, sir.
All right. Ananya, you were confused or
I'm doing it like
okay. Amay? Okay. What is a cyclic quadrilateral, guys? Do you know what is a cyclic quadrilateral?
Yes, a quadrilateral inside a circle.
A quadrilateral, that circle, I didn't get it. I mean, a quadrilateral inside a circle?
Yes.
Okay. So, do you know specific property for a quadrilateral? Like, what specific property does a cyclic quadrilateral has? Do opposite angles sum up to 180?
Yes, sir.
Okay, so angle 1 plus angle 2 is equal to 180. Similarly, this angle 3 and angle 4, they add up to 180. Okay. All right. So from your workbook, your homework is you have to solve all of the question till like all the way till question number 23. Okay. We have done some of the question in the class. You can leave that questions and the rest of the questions you have to do as your homework. Okay. We'll solve one more question now. Okay, see this question. We have to prove that opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center. So tell me, is the quadrilateral inside the circle or outside the circle?
They're inside.
The quadrilateral is inside the circle. Sure. It's written circumscribing. So circumscribe means that the quadrilateral is outside the circle. When it is inscribed, it means that the quadrilateral is inside the circle. Okay. So the question is saying you have a quadrilateral. Let's say it looks like this, right? And there's a circle which is inside the circle, which is inside the quadrilateral. What you have to prove is that the opposite sides of circle, okay. Okay. So basically the question is saying that they prove that the opposite sides of the quadrilateral circumscribing a circle subtend supplementary angles at the center. So this is the quadrilateral and this is the circle. The opposite sides are this and this. So you have to prove that angle 1 plus angle 2 is equal to 180. And similarly, you have to prove angle 3 plus angle 4 is equal to 180. Try this question once. Okay, see what we'll do is we'll construct this line. This line, and this line. Okay, let me name the angles so that it becomes easier for us. So let's say this is angle 1, this is angle 2. Okay, let me name this as 5, 6, 5, 6. Yeah, let's say this is angle 5, this is angle 6, this is angle 7, this is angle 8, this is angle 9, this is angle 10, 11, and 12. Now see guys, this D point is making two tangents to the circle. Let's say this is E, F, G and H. Can we say that DE and DF are the two tangents to this particular circle? Yes or no? How many of you agree with it? That DF
Yes.
and DF and DE are the two tangents. So since DF and DE are two tangents, can I say that angle 12 will be equal to angle 5? Because since these two tangents will subtract, like the angle will get bisected, this particular angle.
Yeah.
Similarly, from point A, can I say that AF and AG are the two tangents? So I can say angle 6 will be equal to angle 7. Right? Now again, B is making two tangents, BG and BH. So again, I can say that angle 8 will be equal to angle 9. Similarly, C is making two tangents, CE and CH, and I can say angle 11 will be equal to angle 10. Right? Also, I know that angle 5 plus angle 6 plus angle 7 plus angle 8 plus angle 9 plus angle 10 plus angle 11 plus angle 12. They sum up to 360 degrees. Yes or no?
Yeah. Yes.
Okay. So angle 8 is equal to angle 9. Angle 6 is equal to angle 7. So I can write angle 9 as angle 8. I can write angle 9 as angle 8. So, okay. Angle 5 plus angle 6 plus angle 7 plus angle 8 plus angle 8 plus angle 10. Okay. Write down this till this step and like let me know if you have any doubt till this particular step. The main logic is that these angles are equal because from D we are making two tangents DE and DF. So these two angles will be equal. Okay. So it's just that you have to substitute like these values after this. So angle 12 is equal to 5. So angle 5 can be written as angle 12. Angle 6 can be written as angle 7. This is angle 7 itself. This is angle 8. Angle 8. Angle 10 is equal to angle 11 plus angle 11 plus angle 12. So you can say that you can clearly see that for each pair of angle, see we have 2 times angle 12, we have 2 times angle 7, we have 2 times angle 8, we have 2 times angle 11. So therefore I can say that 2 times of angle 7 plus angle 8 plus angle 11 plus angle 12 is equal to 360 degrees, right? Therefore, angle 7 plus angle 8 plus angle 11 plus angle 12 is equal to 180 degrees. So this is what we had to prove. देखो angle 7 plus angle 8 क्या है? Angle 2 है. ये पूरा हमने angle 2 माना था.
Yes.
So angle 7 plus angle 8 is angle 2. Similarly, angle 11 plus angle 2 हमने क्या माना था? Angle 1.
Angle 1.
So angle 1 and angle 2 they add up to 180 degree. This is what we had to prove. ओके, सो बेसिकली तुमको याद क्या रखना है, और इसका प्रूफ भी तुमको आना चाहिए वैसे तो. सो ये क्वाड्रिलैटरल है, इसके अंदर अगर एक सर्कल है तो ऑपोजिट एंगल्स का सम होता है 180. I mean this angle and this angle add up to 180, and this angle and this angle add up to 180 again. So if this is 1, 2, similarly angle 3 plus angle 4 is also equal to 180. Okay. On the application of this, try this particular question. Okay, Ritvik, correct. Ananya, Abhishek. Oh, sorry, yeah, Ananya and Abhishek and Amay. Abhishek, correct. Ananya, are you confused? Okay. Ananya, correct. So the logic was very simple, that the opposite angles sum up to 180. So this angle and this angle will sum up to 180. So angle COD plus angle 1, like plus 125 degrees, is equal to 180. From here you can say that angle COD will be equal to 55 degrees. Okay. And I guess you know your homework. The homework is you have to solve till 5.2.23. Okay.
So we have to start solving from 5.1.1, right?
Yeah, sorry, 10.2. Yeah. You have to start solving from the first question and go up till second level के 23rd question.
Okay, sir.
Okay. समझ आया सबको आज जो हमने पढ़ा? कोई डाउट है?
No, sir.
No, sir.
Great. So let me stop recording.